All right, math 3. We are going to start graphing and putting in what is called asymptotes today into our graph. So I will do the best I can with explaining this. It's kind of a hard concept right at first. But let's go ahead and go through some of these problems that we are going to do. Okay. All right, first of all, and I will have this on your Google Classroom, you're going to be asked, like, where are there holes? So identify the types of discontinuity. Continuity means it's continuous. So discontinuity would mean where it's not continuous. All right, so sometimes there are actually holes in the graph that cannot happen, and it tells you here what you need to do. You factor the numerator and the denominator. Simplify it down. So that was like when we were doing our multiplication and we put them in parentheses, we canceled out. If anything cancels, then there is a hole. If there's more than one thing that factors out, there's more than one hole. All right. Find the ordered pair x and y, substitute the x into the simplified equation and get the y. All right, so the holes don't happen too often, but they do. All right, more importantly here is your vertical asymptotes. All right, vertical means when you're going up and down. What an asymptote is, it's kind of a dotted line that the graph approaches, but it won't cross it. All right, so how to find your vertical asymptote? It says set the simplified equation denominator equal to 0. So once you factor the bottom, you set it equal to 0. We kind of did this before. It's where when you have excluded values, I believe is what we called them earlier. When you have excluded values in your denominator, those are your vertical asymptotes. Your horizontal asymptotes, which are going across like this, you have two cases, and you use the simplified equation for this. If the degree of the denominator is equal to the degree of the numerator, we did the degrees of the equations a long time ago. So if the degree of the denominator equals to the degree of the numerator, then your horizontal asymptote occurs when y is equal to the ratio of your leading coefficients. That means, like, if your coefficient on the top is a 3 and the bottom one's a 4, then at 3/4 you're going to have a horizontal asymptote. If the degree of the denominator, which is the bottom, is greater than the degree of the numerator, then your asymptote is going to be at y equals 0, which happens to be your x-axis. All right, on your slant asymptote, so your slant will be like a little dotted line that goes diagonally across. It's going to occur if the degree of the numerator, that's the top of the fraction, is 1 degree larger than the denominator. Then you use your long division that we learned prior to this, and your finished answer will be in the form of y equals mx plus b. The mx plus b is what's at the bottom when you use your long division, okay? So you will do it, and it will just be a line. You should remember how to graph y equals mx plus b. This is your initial value. There's your slope, and it will be a dotted vertical or diagonal line like that for that. Okay, so let's go through this one right now. The first thing we need to do is look down. We are going to find our vertical asymptote. So you set the simplified equation equal to 0. So on this particular equation, you are going to set this equal to 0. So at 2, you would set x minus 2 equal to 0. So at 2, you're going to have a vertical asymptote. So a vertical asymptote, okay, and verticals, you're up and down, okay? So you're going to have when x is equal to 2. All right, holes are when things divide out. Well, there's nothing that divides out here. A horizontal asymptote. All right, so to find your horizontal asymptote, it's when the degree of the numerator is equal. Well, it's not. When the degree of the denominator is greater than the thing. So the degree of the numerator is 0. The degree of the denominator is a 1. It's a 1 degree. This one has x to the 0 power, so it's not there. It says y is equal to 0, okay. Why do we have it at -1? It should be at y equals -1. Okay, And then we need to find, let me come back to that. We need to find our x-intercepts and our y-intercepts. Well, we've done this before as well. So your x-intercept is where your y is equal to 0, and your y-intercept is when your x is equal to 0. So I'm going to start with my y-intercept. So I'm just going to simply put 0 right here. So 0 minus 2 is negative 2. So I have a negative 3 and a negative 2, which is positive 3 halves. Minus 1 is 0.5. Okay, just doing your math there. Then you're going to find your x-intercept. That's when your y is equal to 0. So I'm just going to come over here and do that. I'm going to have 0 equals, I'm going to move that negative on the top, x minus 2 minus 1, and I'm going to solve for x. All right, so by solving for x, I'm going to add the 1 over. So I have a negative 3 over x minus 2. What I'm probably going to do is here is just, I can multiply by the denominator, which is x minus 2. I'm just going to cross multiply. I'm going to take 1 times x minus 2, which is x minus 2, and I'm going to set it equal to negative 3. I'm going to add my 2 over. So negative 3 plus 2 is negative 1. So my x is negative 1. Okay. Okay, I still want to do my horizontal asymptote. My horizontal asymptote is at negative 1. And the only thing I can think, okay, on here it would be at y equals 0, but since you have this minus 1 right here on the tacked onto the outside, that you have to shift the whole graph over, which is why the horizontal asymptote is going to be when y is equal to negative 1. All right, this right here, if that was not here, you have, you would have it at y equals 0 because the degree in the denominator is greater than the degree in the numerator, so it would be at y equals 0. Because of that, it has a shift of negative 1, so you're going to drop it down 1. All right, so your vertical asymptote is at x equals 2. So at x equals 2, you're going to kind of make a dotted line. That is an asymptote. I cannot cross that line with the graph. All right, then we also have the horizontal asymptote at negative 1, so I cannot cross here. Okay, if you notice, I now have like kind of a new little quadrant set over here and over here. We know we are crossing the x-axis at negative 1 right here. And we know we are crossing the y-axis at 0.5, which is right here. Oh, sorry, that's negative. Positive 0.5, which is right here. All right, so what I'm going to do, your asymptotes, remember you can't cross it. Well, I know how this one goes because I have the points. So I'm going to skimmy along here. I'm going to hit these points. As I approach that asymptote, I'm going to be right here. All right, now what I need to do is basically I need to know, does the rest of the graph fall here, here, here? What's going to happen? So I am going to pick, let's say, any value over here, okay? Anything on the other side of this asymptote at 2. So I'm going to pick 4. I'm going to go and I'm going to put 4 in here. And I get 4 minus 2, which is 2. So this makes it negative 3 over 2, which is negative 1 1/2, minus 1. So I have negative 1 1/2 minus 1, which is negative 2 1/2. So when I plugged in the 4, I got negative 2 1/2. So 4 gave me negative 2 1/2, which is down here. All right, so what's going to happen? That means my graph is right here in this little section of it. So it's going to come up and curve. Okay, it's almost like you're making like little parabolas type of a thing. I don't know how you want to look at inside of your quadrants. You have this quadrant, this one, and this one. All right, so you just kind of test a point and see where it goes. All right, let's come over here. If it asks you for your discontinuities on here, which it did, your homework does not have that, but you have a discontinuity here at 2. It's always where your vertical asymptotes are. Okay, let's start with this. Let's do our vertical asymptotes, all right? And again, I will have this worksheet online for you. So you just wherever your denominator cannot equal 0. So my denominator cannot equal 0 at 0. So x equals 0. I have an asymptote, which is your y-axis. All right, to get our horizontal asymptote, Okay, the horizontal asymptote. We come up here and it says when the degree is equal, no, they're not equal. When the degree of the denominator is greater, then it's y equals 0. Well, the degree here is a 1. There is a 0 here, so it's larger. I'm not adding or subtracting anything, so there's no shifting. So it's when y is equal to 0. So both of these are on the axes, okay? So right here is my vertical, across here is my horizontal, so I'll be like swooping somewhere in one of these two quadrants. All right, the next thing we need to do is find the intercepts. Okay, there's no holes on here. Well, there's not going to be an x or a y intercept because I can't cross over these axes, so there's no x or y intercept. So you can test a number to the left of this one right here. So let's just take -2. We're going to plug in a -2 here. Well, if I put a -2 in, I get this negative will make it become a positive. So I just get 1/2. So at -2, I'm going to be at a half. All right, if I want to plug in -1, I'm going to be at a +1. So what's going to happen is it's going to come like this. Okay, now I got to decide over on, so out of these two, I was above the x-axis. When I come over here, I want to know, is it going to be above the x-axis or below the x-axis? So I'm going to pick a number over here. Let's just pick 2. If I plug 2 in there, I get -1/2. Okay, if I were to put a 1 in here, I get -1, which is right here. If I put 4 in here, I'm going to get -1/4. All right, so what it's going to look like is that, okay? All right, so coming down to this one, let's do our vertical asymptote again. Our vertical asymptote is what makes the denominator 0. So when x is equal to 1, I'm going to have a vertical asymptote. So it's going to be right here. Okay, here's my dotted line. To get my horizontal asymptote, again, my denominator has a larger degree than this one because it's 0, but I have a shift of 2. All right, so my horizontal asymptote is really going to be when y is equal to 2. Normally, it would be y equals 0. If that wasn't there, I would say y equals 0, but I am shifting it up 2. All right, so I have it right here. Okay, those are my asymptotes. And again, I have this quadrant, this one, and this one. All right, so to go to, let me get my, there are no holes because nothing factored out. My x-intercept, all right, so my x-intercept, where am I going to cross that x-axis is when my y is a 0, and to get my y-intercept, that's when my x is 0. All right, so I'm going to do my x first. I put 0 here. I get -3. -3 plus 2 is -1. So I know I'm crossing my y-axis at -1. So that means I'm going to be here in this quadrant right here. Which is also going to find my x-axis, or my x-intercept, but we can go ahead and do that. So to find my x-intercept, I'm going to put my 0 here. So if I put 0 here, I'm going to subtract 2 first. So I'm just going to do that. Subtract my 2 over 1 is equal to 3 over x minus 1. I take 2, distribute it across. I'm just cross multiplying, taking 2 times that. That's -2x plus 2 is equal to 3. Solving for x, I subtract my 2. Gives me 1, divide by that gives me -1/2. So I'm going to cross my x-axis at -1/2, which makes sense because that's right here. So what's going to happen is I'm going to come skimmy up through this. I got to make my points come down here. All right, so that's between these two. Now over here, do I want to graph up here on this side of my vertical asymptote, or am I graphing down here? All right, so again, pick one of your x's. It does not matter which one. I'm going to go ahead and do 4. All right, so if my 4 is above the 2, then I'm graphing up here. If my 4 is down here, then I'm graphing down here. So I'm going to put 4 right here. 4 minus 1 is 3. 3 divided by 3 is 1. 1 plus 2 is 3. So at 4, I get 3, which means my graph is going to come up here, and I just kind of swing it in. Okay, so that is all of that. Let's go to the back of this worksheet, which is going to be a little bit more complicated in the fact that we get to factor this time, which is also a little more exciting. So we might get a few holes or something like that in our graph. So let's see. All right, so the first thing we want to do is factor this top. So I'm going to factor in, I'm going to pull out an x. I get an x plus 2. Okay, down here, what multiplies to give me negative 6 adds to get me 1, which is a positive 3 and a negative 2. Okay. It doesn't look like anything factors out, so that's not going to make any wholes, because if you remember up here in our wholes, we factor, simplify, and if anything cancels, then you're going to have a hole in the graph, which is literally when I go to graph it, I'm going to put a hole in the graph and go on with it. So there are no holes. All right, the next thing we're going to do is try to find our vertical asymptotes. Okay, remember our vertical asymptotes occur when the bottom is a 0, the denominator is a 0, so it's going to occur at negative 3 and a positive 2. So when x equals negative 3 and a positive 2, so we have 2 of them this time. So you're going to have a vertical right here at negative 3, and you're going to have a second vertical one here at 2. Okay, the next thing we're going to do is we're going to try to find our horizontal asymptote. So I look, well, our degrees, this has a degree of 2. Remember, it's your degree is your highest exponent. This has a degree of 2. So the degree is equal in the numerator and the denominator. So I want the ratios of the leading coefficients. So I look here, the leading coefficient here is 1, the leading coefficient here is 1, so I just want the ratio, which is 1 to 1. So my horizontal asymptote is going to be when y equals 1. Okay, and if there was a shift again, if you had a plus something out here, you would need to shift it from the 1. All right, but there is no shifting, so we're at 1. Okay, so it looks like that. So we actually have 3 regions here. We have the region to the left of this asymptote, we have this middle region, and we have to the right of that asymptote. So when I'm over here, I'm either going to be graphing above or below the horizontal. When I'm here, I'm going to be graphing above or below, and when I'm here, I'm graphing either above or below. All right, so we need to figure out where that is. All right, so let's go through, how about we find our x-intercepts? Our x-intercepts are what's going to make the y a 0. Okay, so find our x-intercepts. It's when y is 0. Okay, so I'm putting when our y is, and the only way to get our y to equal 0 is to get a 0 on top. So I'm going to look over here, what forces this top to be a bottom. Remember, this is undefined down here. That's why I have asymptotes. I can have a 0 in the top of it in the numerator. So that's what I'm looking at. So at 0 and negative 2 are going to be here. So at 0, 0 and negative 2, 0. So I know I'm going to cross this axis at 0, 0 and negative 2, 0. Okay, so I'm crossing at both of those. To get my y intercepts, that is when my x is 0. Okay, that's when my x is 0. So I'm going to go put a 0, and for all the x's, well, if I put a 0 here and here, I get 0, so it really doesn't matter what happens down here. 0, 0, which is, I already have it as my x-intercept, so it doesn't change. All right, so here's what I'm going to do to decide, and there's a couple of ways. You can go and pick a point to the left of this asymptote, do the math. All right, we already know this one has to be below the line, okay? So this one is going to be a parabola shape, kind of. It kind of goes like this, just awkwardly. Okay, we just need to decide over here, am I going to be graphing above, below, above, or below? So there's a couple ways you can do that. Like I said, you can pick a point, take -6, plug it in for all your x's, and see if it's positive or negative. So all I care really about if it's a positive or negative. All right, so what I'm going to, well, do I really care? No, let's just do it. All right, so let's take -6, put it right here. If I put a -6, I get -6. I'm going to put a -6 in here, which gives me -4. All right, so on top I have a 24. On the bottom, I'm going to put -6 right here, which is -3. I'm going to put -6 here, which is -8. -3 times -8 is positive 24, so I get the number, well, I can't get 1. What did I do wrong here? So -6 here, -6 here, multiply gives me 24. If I put -6 here, I get -3. If I put a -6 here, I get -8. which is a positive 24, gives me 1. Okay, so 1 is right here. No, it's going to be really close to that. So it is above. You can try your 8. What happens when I stick 8 in here? Let's try it with an 8. If we stick 8 in here, well, it doesn't really matter. It's going to be above. Okay, you're going to skim me along. Okay, over here we need to pick a number to the right of this asymptote right here. So let's pick a 4. We're going to put 4 in here. If I put 4 in here and a 4 in here, I'm definitely going to get a positive number. And let's see, stick 4 in there. You're going to get 4. 4 plus 2 is 6, so you get 24. If I stick 4 in here, I get a 7. If I stick 4 in here, that's going to give me a 2, which gives me 14, which is like 1, and it doesn't really matter. It's almost 2. It's quite almost to 2, but it's 1 in whatever fraction, doesn't really matter. So when we stick a 4 in, it was up here, so it's going to be above that asymptote. That's all I really care about. So that's what that graph looks like. All right, number 10. Okay. Again, this will be the last one we do. We are going to factor the top, so I'm going to pull out an x, and you get x minus 1. On the bottom, it looks like I can pull out a negative 3x, and when I do, I get an x squared plus x minus 6. All right, so double check. When I do redistribute that, I get a negative 3x cubed. That gives me a negative 3x squared, and that will give me a positive 18x. All right, then I'm going to go ahead and factor this. So I have my 3x. This will become x plus 3, right? And x minus 2. That's what that becomes. Okay, I'm going to go through and I'm going to, that factors out, and because that canceled out, I am going to have a whole. All right, because if anything cancels, then there is a whole. So the 0 canceled, the x and the x, so that was your 0. So we are actually going to have a whole at 0, okay? And you can, and what it does say, it says plug it back in, but I know since it was pulled out 0, 0, it's going to be my whole. Okay, so you have a whole at 0 when x is 0. All right, on the bottom, there's your vertical asymptotes, what it cannot equal in the bottom. So your vertical asymptote is going to be when x is negative 3 and x is a positive 2. It's kind of like we had this last time, I think, the same one. So at negative 3, positive 2. All right. When I come to our horizontal asymptote, it says here, use your simplified equation. So my simplified equation technically is x minus 1, and down here I still have that negative 3, and I have x plus 3, x minus 2. Here would be a squared equation, here would be a single equation. Therefore, my denominator is greater than my numerator, so y equals, so my horizontal asymptote is when y is equal to 0. All right, so y is equal to 0 is right here. Okay, which is good. That's kind of why we have a disconnect right here too. And then let's see, what else do we need? I guess we can do our x-intercept. Our x-intercept is when our y is 0. What's going to cause this to be a 0 when the 0 is on top? So 1. So my x-intercept is at 1. So I'm going to cross the... Okay. Oh. All right. And then we can go and check and see, you know, what does what. So here is one of our vertical asymptotes, so we can pick one of the numbers over here. Really, I just worry about if it's positive or negative. So what I'm going to do is I am going to just put in, all right, I'm going to this equation right here. I'm going to stick in, it doesn't matter, I'm going to stick in, let's say, -6. So if I stick a -6 in here, I'm going to get a negative on top. I get -7, but I'm not worried about it. This is going to be a negative, it's -3. If I put -6 in here, this parenthesis will get me a negative. This parenthesis will also give me a negative. And how many negatives do I have here? Negative, 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 -4, which means the overall problem is going to be a positive. I just need to know if I'm going to be up here or down here. So it's a positive. All right, the next section, this one's kind of goofy. I don't know. We might need to go to like a Desmos and take a look at this one, what it looks like. The book has it kind of coming like this and like making a hole right here, but we have to cross the, oh, the my bad. The x-intercept is at 1. At 1. I don't know why I put it on the y-axis. That's going to make a lot more sense. So it's right here. So what this one does, it kind of comes like this, and it has a hole, and it goes up, you know, like that. So over here again, I want to know, am I above or below? So I'm going to take, like, let's just say the number 4. You can use 6, 8. It really doesn't matter. I just want to know positive or negatives. All right, so going back to this equation, I am going to stick a 4 in for the x. So if I stick a 4 here, I'm going to get a positive number. This 3 will always be a negative because there's no x associated with it. If I stick a 4 in here, I'm going to get positive from this parenthesis. If I stick a 4 in here, I'm going to get a positive because 4 minus 2 gives me a positive number. Now, if I look through here, don't I have one negative, which tells me my graph is going to be in the negatives, all right, which means my graph is going to be down here. All right, so this one ended up being a positive. This one ended up being a negative. So I'm going to come up here. I'm going to skimmy along there, and here I'm going to skimmy along here like that in the negatives. Okay, I don't know, that's kind of the gist of it. These are not easy. If you need to, you probably can go to Desmos to kind of look at that, but you do need to list all of these, so you kind of need to know where they're coming from. So if you're unsure how to find these, again, I have this great worksheet here that explains how to do all of that. Let me actually do number 11, because I believe, well, let me see. We have a slant, I feel like we have a slant asymptote on number 11 because the numerator is exactly 1 degree more than the denominator, okay, on 11 and 12. So let me do these, 11 and 12. All right, let me do this one. Okay, so the first thing you're going to do is factor this out. Let's see, we're going to do x minus, no, we need to do x minus 2, x minus 3. X minus 2, x minus 3. That adds to get me -5, multiplies to give me a positive 6, and we have the -4x down here. All right, so nothing canceled out, so I don't have any holes. My vertical asymptotes, if you remember, what make the denominator 0, so in this case, it's going to be when x is 0. All right, which is, this is my vertical right here. Okay, to find my horizontal asymptotes, okay, so I'm going to go to my little cheat sheet over here. If the degree is equal, then I want the ratio. If the degree is greater, I want that. Well, it's neither. The denominator does not equal, and the denominator is not greater, because if you take a look at the problem, the numerator is greater, so my horizontal asymptote is a none. Okay, it does not have one because the numerator has a higher degree than the denominator. Okay, but that does mean we have a slant. So what I'm going to do is use my long division. Okay, so this will be a good test. I'm going to take that divided by that. So it's x squared minus 5x plus 6. All right, and if you remember, we say how many times, what do I need to multiply this by to get to here? And that is a -4x. So I take, oh, no, 1/4, sorry, 1/4 x. So I'm going to take 1/4 times that, and that gives me x squared. And then I take well, that's all I can do. I guess there's nothing more to do it to. That subtracts away. I bring this down. All right, and I start over. What do I multiply this by to get to here? So that's going to be a positive, let's see, 5/4, I believe. Positive 5/4, because if I take a negative 4 times that, I get a negative 5x. So negative 5x, subtract that away, and I'm remainder is 6, okay? And I don't worry about the remainder. Right here is in the form of y equals mx plus b. That's my slant asymptote. So what that says is I'm going to start at, this is 1 1/4. So I'm going to start at 1 1/4 on my y-axis, about right here. Then from there, I'm going to go down 1, right 4. So down 1, right 4. Down 1, right 4. Okay. Or I can go up 1 and left 4. Up 1, left 4. Okay, so I have a little asymptote right here. Okay, so I'm looking at this little funky quadrant right here, this little quadrant here, or does it go right here or here? Okay, and again, what you're going to do is put in, let's say, your -2. Okay, you're going to put it your -2, and you're going to notice it falls up here, which means it kind of goes like this. All right, then you're going to come and you're going to pick something to the right of this axis. So you can do like 2, 4, 6, 8, doesn't really matter, 3, 5, it doesn't matter. Plug it into your equation up here, and you're going to find that when you do that, it falls in down here. Okay, so this one's going to come and kind of go like this. Okay, and that slant asymptote was right here. Again, the slant asymptote was because the bottom, the denominator, had a lesser degree than this one. So you use your long division, which will always put you in the form, I don't care about the remainder 6. You just want to know what happens up here, and it was in the form of y equals mx plus b. Graph your linear asymptote like that, and that's going to get you there. All right, and the reason there was no horizontal asymptote was because the degrees weren't equal, nor was the bottom greater than the top. Okay, so that was a none, and your vertical asymptotes always occur right here, what makes it equal 0. If you wanted your x-intercepts, it's what makes your y, it would have been, my x-intercepts would have been at 2 and 3. All right, so my x-intercepts where I cross, I would have crossed here, and I would be crossing here. So that's why this one kind of looks like this. So I guess we wouldn't have even had to try a number over here, because I know it had to be down here, because my x-intercepts occur when my numerator is 0. I want to know, when does y equal 0? Okay, if you need to look up YouTube videos, I know this is really long, not a great time to try to explain all of this, but let me know if you have any questions.